Welcome to the fourth video for our fifth class time in the series of lecture videos for the notes. We ended the last video having discussed the first two rules of the systematic way to name branched alkanes. In it, we saw that the first rule is to find the longest chain in a molecule and name it. And there were caveats. If there were two or more chains of equal length, then the chain with the largest number of substituents turned out to be the base stem chain. The rule 2 was to name all the groups attached to the longest chain as alkyl substituents, methyl, ethyl, propyl, and if the group was branched, you would repeat rules 1 and 2. It might be helpful for you to see, as an example, this particular one, 2,4-dimethyl-3, 1-methyl-ethyl pentane, or 2,4-dimethyl-3-isopropyl pentane. The 1-methyl-ethyl is the IUPAC system of nomenclature, so we could go ahead and diagram this out. Our longest chain, whichever way you number it, is going to be 5 carbons. 1, 2, 3, 4, 5. You can see at the 2 and the 4 carbon of our base stem chain we have methyl groups, so we insert a di prefix and then we name the groups methyl. And then at carbon 3 we have a 1-methyl-ethyl group. How do we get that 1-methyl-ethyl group? Well, we take this whole entire group and we number the carbons again. 1, 2. My longest chain is a 2-carbon chain. That's the ethyl stem. At the 1 carbon of that 2-carbon chain, I have a methyl group. So that is how we get 1-methyl-ethyl. So continuing with our handout, Rule 3. Number the carbons of the longest chain starting with the end that is closest to a substituent. And caveat, if there are substituents at equal distances from the two ends, the substituent to come first in alphabetical order gets the carbon with the lowest number. So for example, ethyl comes before methyl, so we have to number this octane in the manner where the ethyl group gets the lower number versus numbering the base stem chain, the octane chain, where the methyl group gets the lower number. So this is not correct. This is correct. Second caveat, if there are two identical substituents at equal length from both ends, then you use the first point of difference rule, which leads to the lowest set of substituent numbers to be used. So for example, this molecule would be 3,5,10 trimethyldodecaine, not 3,8,10 trimethyldodecaine. Why? Because 3,5,10 is a lower set of numbers than 3,8,10. So we have to number it from left to right. Rule 4. Write the name of the alkane by first arranging all substituents in alphabetical order. If a molecule contains more than one of a particular group, use the prefix di, tri, tetra, penta, hexa, hepta, etc. Caveat, the prefix is not used to decide the alphabetical ordering of substituents. So let's try drawing some molecules, and I think it's actually easier to draw a molecule from a name than it is to name a molecule from a structure. But that's just the way I approach things. So for example, let's try 2,3,5-trimethyl-4-propyl heptane. Well, where do I start? Heptane seems like a pretty good place to start. Heptane is 7 carbons. So 1, 2, 3, 4, 5, 6, 7. I have my 7 carbons. I can even number them. Why not? 1, 2, 3, 4, 5, 6, 7. So what does this tell me? At the 2, 3, and 5 carbons, I have what kind of groups? I have methyl groups. There are 3 of them, so it's a 2,3,5 trimethyl naming. So at 2, I have a methyl, At 3, I have another methyl group. At 5, I have a methyl group. What does this say? At carbon 4, I have a propyl group. Well, a propyl group is 3 carbons. 1, 2, 3. So we've completed our first example. How about 6-ethyl 2,2,3,5 tetramethyl nonane? Well, nonane clues me in that there are 9 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it doesn't really matter. It's all arbitrary. I could number left to right or right to left. Why don't I try that? 1, 2, 3, 4, 5, 6, 7. And I don't mind 8, 9 if students write numbers on the structures that they draw. So at the 6 carbon, I have an ethyl group. That's 2 carbons. 1, 2. Then 2, 2, 3, 5, I have 4 methyl groups, but 2 of those methyl groups occur at the 2 carbon. So I'll go ahead and put them on there. 1, 2 methyl groups. And then there's 1 at carbon 3 and 1 at carbon 5. All right, great. Also, it's good if you're able to name halide substituents. So we often encounter hydrocarbons where we like to put handles on them in terms of halogens. So here we go. This one is 4-bromo 2,2-dimethyl pentane. And this guy is 3-chloro 2,2,3-trimethyl hexane. Continuing on with our handout. It's good to also be able to name cyclic alkanes as well as iodinated hydrocarbons. So for example, here we have a bromocyclohexane. Here we have 1,3-dichlorocyclopentane. And over here, using IUPAC, we have 1-methyl-4, 1-methyl-ethyl cyclohexane. So again, we could number this, bring 1, 2, 3, 4, 5, 6. At the 1 carbon, we have a methyl. At the 4 carbon, we have a 1-methyl-ethyl. Methyl comes before methyl-ethyl in the alphabetic system of distinguishing these groups. Over here we have 2-iodopropane. It's not a cyclic alkane, it's iodinated, but you can recognize there's the iodine. Here we have 1-methyl-2-propyl cyclohexane. So that's a lower set of numbers than 1-methyl-6-propyl cyclohexane, right? You want to number to get the lowest set of numbers. So that pretty much does it for our systematic rules for naming. I will see you in the next video where we'll discuss an interesting sort of problem that we might encounter in a test format at some point.